Hi, dear students. Now we are going to study about the parallel operation of transformer. Parallel operation of transformer. So why we are going to connect the transformers in parallel? The transformers connected in parallel to share the load. To share the load. Why the transformers are connected in parallel? The transformers are connected in parallel to share the load. Transformers are connected in parallel to share the load. So why see here? So when we share the load, for example, a single transformer does not sufficient to supply the load. Not sufficient to supply the load. So here, the load capacity is greater than the transformer capacity. Load capacity is greater than the transformer capacity. At that time, the excess amount of the load can be shared or help with the another transformer. So how we can take in the help with the other transformer? The second transformer is connected in parallel. The transformer is connected in parallel. See that here, parallel operation of transformer. We are going to study about the parallel operation of transformer. Sometimes it becomes necessary to connect more than one transformer in parallel. It becomes necessary to connect more than one transformer in parallel. So when we are connecting the more transformers are connected in parallel, so here supplying excess load of rating of the existing transformer. The load capacity of the load capacity is greater than the rating of the existing transformer. So in that case, if we are connecting two or more transformers in parallel, two or more transformers are connected in parallel, same supply on primary side and the same load on the secondary side. So how if two are defined parallel operation of transformer or parallel connection means if two or more transformers are connected to a same supply on the primary side to a same load on the secondary side, then it is called as parallel operation of transformer. Very important for 2 marks. Defined parallel operation means the two or more transformers are connected. The two or more transformers are connected. The two or more transformers are connected to the same supply on the primary side, same load on the secondary side. Then it is called parallel operation of transformer. Parallel operation of transformer. What is the necessary? See that. What is the necessity of parallel operation? What is the necessity? So, necessity of parallel operation of transformers. Necessity of parallel operation of transformer. Why parallel operation of transformer is needed? So, what is the necessary? The necessary is when we connect the transformers in parallel, here four important points are there. What are those four important points? One is, what are the four important points of transformers are connected in parallel? The first one is increased load demand. Increased load demand. When the load is increased and it exceeds the capacity of the existing transformer. Okay, that is the load capacity is greater than the existing transformer, rating of the existing transformer. Another transformer may be connected in parallel with the already existing transformer, already working transformer to supply the increased load. Supply the increased load. For example, so we are unable to carry the weight of 100 kgs. Okay, but the weight of the product is greater than 100 kgs. So we are unable to carry the more than 100 kgs. So that time we have taken the help with another person. Taken the help with the another person. Same as in parallel operation, the load capacity is greater than the capacity of the transformer. So then that load, extra amount of the load, or that load can be shared with the another transformer equally. And next one, that is the first one, increase the load demand. And next one, non-availability of large transformer. Non-availability of large transformer. If the load capacity is more, so at that case, we require the large amount of transformer, large capacity of transformer. In that case, that large capacity of the load can be equally shared to the n number of transformers. There is two number of transformers or three number of transformers. That is, if a large transformer is not available, which can meet the total requirement of the load. Two or more small transformers can be connected in parallel to increase the capacity. Here, one large transformer is not available to supply the load. That time, with the help of two small capacity of transformers or three small capacity of some transformers, we are supplying the energy to the load. And next one, increased reliability. So what is mean by increased reliability? Here, multiple transformers are running in parallel. Multiple transformers are running in parallel is nothing but three transformers, four transformers, or five transformers are connected in parallel. If a fault occur in any one transformer, for example, four transformers are connected in parallel, the fault occur in the third transformer. So then the third transformer can be removed from the working condition and the load can be shared to remaining three transformers. The fourth transformer load can, the third transformer load can be shared to another transformers 1, 2, 4 without interrupting the continuity of the service. So that is the faulty transformer can be taken out for the maintenance. The transformer can be taken out for the maintenance. And next one, and one more important one. So here, transportation is easier to carry the small capacity of transformer. So here, single three-phase transformer, the size is more. So the weight of the transformer, for example, the high capacity of the transformer means the size is more. In that case, we are carrying the small capacity of transformers, 3 or 4 transformers very easily. That is, if the installation site is located far away, then transportation of smaller units is easier and maybe economical. That is about the parallel operation of transformer. So very, very important for 2 marks. Define parallel operation. The two or more transformers are connected to the same supply on the primary side and same load on the secondary side. Then it is called a parallel operation of transformer. If two or transformers are connected, why 2 or 3 transformers are connected in parallel to share the load? And next one, what is the necessity? We are connecting the transformers in parallel. So here 4 necessary conditions are there. What are those 4 necessary conditions? Increased load demand, non-availability of large transformer, increased reliability, transportation is easier for smaller transformer. This is about the parallel operation of transformer and necessity of parallel operation of transformer. Coming to next slide. So what is conditions? What are the conditions of parallel operation of transformer? So just now we discussed about what are the necessary conditions for parallel operation. Now, what are the conditions before going to connect the first they have to satisfy all these conditions. All these conditions fulfill. It is this the answer are going to connect in parallel operation. Those transformers fulfill these points. What are those conditions? So that there are various conditions that must fulfill for the successful operation of transformer. Various conditions that must fulfill for the successful operation of transformer. What is the first condition? The first condition is the line voltage ratio. The line voltage ratio of 2 transformers must be equal. Line voltage ratio of 2 transformers must be equal. That is, line voltage ratio of the first transformer is equal to the second transformer, is equal to the third transformer, is equal to the fourth transformer. Either it is the supply voltage or it is the load voltage. First one. Second one, the per unit impedance. What's it here? The per unit impedance of each transformer should be equal. Per unit impedance. What is the definition of per unit impedance? Z per unit is equal to actual value of impedance by base value of impedance. Z actual divided by Z base. Actual value of impedance is divided by Z base. Actual value of impedance divided by Z base. And one more condition, the same ratio of reactance to resistance, the same ratio of equivalent leakage reactance to the equivalent resistance, equivalent leakage reactance to the equivalent resistance. And next, coming to point of what is the third condition? The transformer should have same secondary winding polarity. Transformer should have same secondary winding polarity. The secondary winding of the first transformer is connected to phase, load, phase and load neutral. The secondary winding of the second transformer is also connected to the second load, phase and load neutral. In case the secondary winding of the second transformer is connected to neutral and phase, So here, due to that, the voltage capacity is more. The voltage capacity is more. So that's why we are checking the polarity. This is about the third point. And next, coming to the point, the transformer should have same phase sequence. Same phase sequence. We are connected. If you draw a phase, these are all having the same phase sequence. This is related to the which type of transformer? Three-phase transformer. And next, come to the point of the fifth point. The transformer should have the zero relative phase displacement. There is a phase displacement between the secondary line voltage of the first transformer, secondary line voltage of the second transformer, secondary line voltage of the third transformer should be zero. Why? Because in parallel condition, which should be the same, voltage should be the same. So first load voltage is equal to second load voltage, second load voltage is equal to third load voltage. So these are the conditions should satisfy. What are those conditions here? 5 conditions are there. The first one is line voltage ratio must be equal per unit impedance and the ratio of X by R. The transformer should have same secondary winding polarity. The transformer should have same phase sequence. So next one, zero relative phase displacement between the secondary line voltages of the transformer. So these are the conditions for parallel operational transformer. So, dear students, the next video I will explain clearly these 5 points. So these 5 points, these are the just brief discussion about the conditions for parallel operation of transformer. Next, in the next video, I will explain you clearly each and every point of the condition for parallel operation of